Hello, hope I am audible. Welcome to the session 2, lecture 8, and we are going to start that what we have done into the previous class, and one by one, very quickly I would go through that what we have done in the last class and last session, and then we would be seeing something more. Okay. So one thing that we have seen that what is the classification problem? Given the item, you want to find out the appropriate labels, and to do this in the machine learning domain, you just first want to find out that what are the appropriate feature. Given any item, you represent those items using the feature. Feature are the handles that tells you about the item. Then you want to train the system and want to utilize some machine learning machinery. One such machinery is a decision tree, and we have seen that it is a kind of tree structure where every node tells that what attribute to test, and when you are going to test one attribute, then you go ahead. Before going forward, I just want a confirmation from anybody that you are able to listen me, hear me. Are you able to hear me? Okay. Can anybody write yes? Okay. Thank you very much. Okay. Because I have changed the room because there was a problem into the last room. I was not able to properly write on the board. So, okay. So we have seen that this kind of model actually gives you the disjunctions of the conjunctions. These are the conjunction. Outlook should be sunny, humidity should be normal, and then you want either this or this, and this is kind of the disjunctions of the conjunctions. We have seen that there are various places where you can apply the decision tree. It is more appropriate for the places when there are error into the data, and also when sometimes some missing attributes problem you have. Then we have seen a mathematical concept that given a database, how to find out entropy. Entropy tells that how much disorderness there into the data. If all the items are actually of the same kind, then there is no disorderness. It tells that the entropy is 0. But when the 50% items are positive, 50% are negative, then entropy is 1. Okay, you see this formulation. So given this data, if I ask you that what is the entropy, then you can find out entropy by just counting how many positive and negative examples are there, and then you can apply into this formula, that is finding out the probability and then log of that probability, and the summation, then multiplication with the -1. You find out that the entropy of this database is 0.94. That we have seen that how we can find out. Then we have defined another notion that is called the information gain, and information gain is actually decided based on all the attributes that are there. Okay, for every attribute, given the database that is S, and given an attribute, what you see for this with respect to this attribute, you create various databases. Means you put one value of this attribute and create the database, put another value of this database, create the database, small database. For all those subset of databases, you find out the entropy and use this entropy, and for here you need the log. But in this formula there is no log. Please understand, when you are finding out the value of information gain, in this formula there is no log. You are not taking any log. You took the log to find out the entropy when you divided the database into the part. You understand? So this is important, that in this formula there is no log. Somebody into the previous session will have some problem that he was thinking that we should also put the SV upon S, then log of SV upon S. That is not correct, because here in this formula there is no log. The log is only to the formula of entropy, and then that you may have solved that given the whenever you considering the attribute, then you have to find out the subset of that database, and using that subset of database you find out the entropy, multiply that entropy with this particular SV upon S value. So similar thing we have seen. Okay. So now the similar thing is here also. In the humidity, the original database was containing 9 positive and 5 negative examples. The entropy was 0.94, and then when you divide it into the high and normal two places, then you find out this database, and where 3 positive, 4 negative, and 6 positive, 1 negative, and this was the entropy for them. And entropy here, to find out this value, you have to apply the log. But after getting the log, after finding out this entropy, you need not to apply the log. You multiply this value divided by the size of this database. What is the size? 7 items are there. Okay, 6 positive, 1 negative, but 7 items are there, divided by out of 14. So 7 by 14, this multiplication, you find out the same thing. I think this would be clear on using this formula. In this formula, you are considering the attribute wind, and you know that when you divide using weak and strong, you find out 8 item over here and 6 item over there. And then into this database, the entropy is 1. Into this database, this week, when wind was weak, the smallest sub database, the entropy was 0.81. So you see that 0.81 is multiplied by 8 divided by 14. Okay, 8 by 14 into the entropy, this entropy. And similarly here you multiply with the 1. What is the value? 6 divided by 14. Okay, 14 is the total number of items into the database. Okay, so in this way you find out, you can solve this thing. And since we have 4 different attributes, humidity, wind, outlook, and temperature, for each of them you find out that what is the information gain, and then you have used this thing. You have seen that the highest information gain is across the outlook, and therefore when you put the outlook at the root, and then you divided the database, and now you have to apply the same thing over here also. For some of the database, you see that all the items are positive, all the items are negative, then you need not to go downward. But other places, for example here, some are positive, some are negative, which one to test, and therefore again you have to apply the same mechanism, saying that for all other remaining attributes, humidity, temperature, and wind, you perform those similar operation, that you divide the database, find out entropy, multiply with the numbers. And here I again want to thank you and for your careful observation that there was a typing mistake. There should be one more term into when you divide the S sunny with respect to temperature, and that would be 1 by 5. And since the multiplication entropy for that particular sub database would be 0, therefore the value is not going to be affected. Okay, but there should be one more term, that is minus 1 by 5. What is the just term? Let me just write down over here, so that it becomes complete. Okay, the term should be, what should be that term? There should be one more term, and I think, let me just quickly cut this, take it out, and let me just write down that term over here. So this is the right representation, minus 1 by 5 into 0.0 is equal to this. This is the right formula. Okay, so this was a typing mistake from my side. Thank you for pointing this out. So we have again seen that the highest value is across the humidity. Therefore, you put humidity over here, and then when you divide, you find out the pure databases. No need to go more deep. Similarly, at this point, if you consider the things, you will be finding the wind is more appropriate. And this is, let's assume that it's a homework for you. You try to find out that how the wind is appropriate, and then again you are going to find out the pure things. One more thing that we have discussed in the last thing, in last session, that we need not to find out that all the roots or the levels should be at the same level. All the leaves should be at the same level, because this leaf is not on the same level. Okay, so so we have seen that if somebody give me this example, and the important thing is that it doesn't contain information for all 4 attributes, but even then we can perform that. Find out what is the classification. How to find out? Given this tree, now you have this tree. If somebody tells you the value of outlook, humidity, wind, again there is a typing mistake, then you just use this tree, and this tree says that give me what the value of outlook. You see that the outlook is rainy, so you come into this part, and then it asks for the wind, and then you see the wind is weak, and then wind is weak, then it's yes. Okay. So somebody is asking when to stop for classification. I think you want to ask that when the classification is given to you, when this particular thing gives you the classification. Whenever you get this kind of terminating node, it is going to give you the right classification, and then you stop. Okay, so this is the slide at which we were here into the previous session, and I think there is no doubt into this. So next thing that I want to give you, that this was the algorithm that we also have discussed, that there are some issues with the decision tree, and that is very important to understand. And one issue that is very important, that given a collection of training example, there could be many decision trees consistent with the example. What do I mean by the consistency with the example? Means, given the example, if I give you a tree, that would correctly classify all the examples. Means, for all the training example, it is correctly going to classify. Then it is consistent. So somebody can ask that how come it is possible that because I am going to use this formulation. So how can it be possible? There could be two possibilities. One, that there would be at some places, if you find out the same value, then what you can do, any value you can select. And other thing also, sometimes you may by yourself you can decide that I'm not going to use humidity or I will use temperature. Use temperature, what is the problem? You use temperature, the data would be divided into a different way, and then you would go down and then you would be able to find out what is the right classification. Sometimes it is also possible. But what is important, that if you are not using humidity, you are using temperature, then your things would be maybe going three level deeper. Here you are only seeing the our solution is available at the 2 level deep, but there you may be seeing the 3 level trees. So your tree would be depth would be higher. Okay, so particularly this point I want to make, that you can create multiple decision trees. They are and all of them are actually classifying your training examples with 100% accuracy, but but they but which one is better? Because if all of them are 100% giving the right classification, which one is better? Okay, so we have seen this particular algorithm, the earlier algorithm that we have seen, this algorithm, iterative dichotomizer. This algorithm, actually ID3 algorithm, it actually selects in the favor of shorter trees over the longer trees. It tries to give you the shorter trees. Okay, select the trees that places the attribute with the highest information gain closest to the root. This is what we do. So given, since I told you this thing, that multiple trees are possible and I'm going to use one of them, which one to choose. So one method is the go ahead, as the ID3 is telling, means you try to build the shorter trees. Okay, but there are other problems, that sometimes you have a problem that how to deeply to grow, because if the tree is very deep and it is 100% correct on the database, then there is a big issue. You know that issue we have discussed in the last class, that if you are very 100% correct on the training data, then you are most probably going to overfit. Means you are going to 100% correct on the training data, but for the new items there would be some error. So this is the problem, that you don't know how deeply to grow. Although the ID3 gives you a handle, but in general you can build the tree by yourself in any way. Then those ways you would not be able to understand that how deeply to go, how to find out the right way. There should be some criteria. Also there is a problem, because at every place you want to find out that what is the value, and that value is only going to see, you are going to match with the with the uh, with the ages. So if it is a continuous value, if I say that it is some value, say if some continuous value is given to you, such as probability, what is the probability it is? It can be any value. So if at node, if some probability, what is the probability that the person would pass in the exam? If this is one attribute given to you, then you cannot put that attribute at any place for the testing, because so many leaves, so many descendant need to be created, that you cannot create by yourself. Choosing an appropriate attribute selection measure is also important. Here we have seen that one appropriate measure was the information gain. Other could also be possible. Missing attribute value. Sometimes when the attribute have missing value at the time of building the tree, then what to do? This is again a question. Attribute with a differing cost. It may be possible. Sometimes it may be possible that the attribute, different attributes may have different cost. What do I mean? That here outlook, temperature, humidity, and wind is given. Okay, so can you find out that what is the cost of measuring humidity and what is the cost of measuring temperature? You know the cost of measuring temperature is very less, because you just see that it may be very cheap, but cost of measuring wind may be higher. Cost of measuring outlook may be higher, and this is very prominent in cases of the medical reports, such as if somebody asks that what is the blood pressure, somebody asks that what is the blood sugar level, somebody asks what is the biopsy reports. So it may be possible that some attributes could be that more costlier than the previous others. So in those scenarios, you want to put attributes which are actually cheaper at the at the at the root level, near to the root level. Okay, and sometimes you also want to improve the computational efficiency, because if it's a long tree, you have to do the long lot of computations. So these are the issues with the decision tree, and the biggest issue that we have talked about was this. From the previous class we are talking that if something is 100% accurate with respect to the data, then it may not be able to generalize. For the new things, I have told you that if your space is such that it contains all the functions, available function, then you will be end up finding out the best function, but the best function is best for the data. So if the new data is coming, then it is a new database. But this database, there would be a different tree that is best, and that tree, this is not that tree, and therefore this tree is going to have the error, and this tree can only give the do the error for the new thing, because for training database it's 100% correct. It means that it is not going to be used for the new training examples. So first time we are going to see the I think formal definition of the overfitting. Overfitting says that if given a hypothesis space H and a hypothesis H, we say that H is overfitting. That when on the training data H is good, but on the testing data some other hypothesis is there that is good, and it is, although that is not good on the training data. So what does it mean? Let me just give you. Let me just write over here that you see that what is the training and testing data. Do you know what is the training and data? What is training data and what is testing data? What is training data and testing data? Some data that is given to you, shown you, most of the time 80% of data is the training data, and 20% of data you keep aside for the testing. And from the training data, if you created some hypothesis, and there let's assume that the hypothesis that you come up, and the accuracy of hypothesis H on the training data say 90% accurate, okay, but when you tested this hypothesis on the testing data, the accuracy was here 60%. Okay, let's assume that this is the scenario. And let's also assume that there is some other hypothesis, H dash, whose accuracy on this testing data is say 80%. But the accuracy on the training data is only 70%. Okay. So which particular hypothesis is better? Can you tell me which hypothesis is better? Can you tell me which hypothesis is better? Okay. H or H dash, which hypothesis is better? H dash. Although you know that you cannot do anything because only training data is given to you. So if given the training data, only the best hypothesis is this. But with respect to, why you are constructing these things? You are constructing these things so that you should be better on the testing data, and on the testing data this second algorithm is better. Therefore H dash algorithm is better. Okay, you understand this important fact. Okay, so this in this scenario we say that this hypothesis is actually overfitting. Okay, this hypothesis is overfitting because we have another hypothesis that is better on the testing data. However, it is not good on the training data. Okay, so can you see this graph? Okay. So this graph says that when you keep increasing size of the tree, means when you increase the size of the tree means the more nodes, more deeper it is, then your accuracy increases. Okay, as the tree increases, as the size of tree increases, it becomes better and better, and therefore accuracy increases, error decreases. Okay, what I'm telling, I think on the training data it is. I think if it is not accuracy, the accuracy increases. Okay, accuracy is increasing. Accuracy is increasing when your size of the tree is increasing. But what happened on the testing data? The accuracy is actually decreasing. Okay, you're going better and better on the training data, but you are going worse on the new examples. This occurs because many other time you have errors into the noise into the data, and so many other things that are possible. So you know what is the overfitting. So how to avoid the overfitting? To one approach is that you stop growing the tree earlier. Means you don't you don't train your uh, tree perfectly. Means before it becomes the perfect, means it there is no error, you stop growing. How you can stop growing? How you can stop growing? Okay, very good question. How you can stop growing? Okay, so this is the tree that gives you the perfect classification. Okay, if I want to say that I want to stop growing at the first level, so what you can do? Okay, let me tell you. Okay, see, very important thing I am going to discuss. Okay, if you say that don't want to go beyond this level, if you say that you don't want to go beyond this level, okay, you don't want to go beyond this level, so essentially you want to say that I don't want to build this tree this deep. Okay, if you don't want to build the tree this deep, so what should be the classification when outlook is equal to rain is there? What should be the classification? The classification, you see the what is the maximum over here. Here you see the yes or maximum, therefore you put yes over here and you remove this part. Is it, do you understand this? That you put yes over here and now we are done. At this place you see, if you say that no, I don't want to grow this. Okay, I don't want to test anything over here. Okay, I want a smaller tree. To make this tree smaller, again you can do the same thing. Can anybody tell what should be the classification over here? Can anybody tell what should be the classification over here? No. Yes, very good, very good. I see a lot of responses from your side, because two no's are there, so you say no. Okay, so this is what the classification I have. So look, in this way I can make my tree smaller. So this tree, what is the advantage of this tree? What is the main part of this thing? That this tree is not good as the previous one on the training data, on this data, on the training data, on this training data, on this training data. Maybe this particular tree which says, what is the tree? That outlook, it only tested the outlook. If it is sunny says no, overcast says yes, rainy says yes. This particular tree is not good on this, because it is going to do some error. But for the new data, this tree may be better. Okay, so this is what I want to bring to you, that is, stop growing the tree earlier before it reaches to the point where it perfectly classifies the training example. And this is the way that you can go ahead or allow the tree to overfit the data. Second could be that allow the tree to the overfit the data. And this is the second. Actually, we have shown this second part, that we have actually build the tree, complete tree. Overfit the data means you have actually build the complete tree, and then post prune means you have cut down something. I have cut down those things. Okay? Recently we have seen the example when I cut down the coconut. I'm going to cut it. So how can you cut it? On what basis you are going to cut? This is a very important thing. So I have told you that I can cut in this way, but I can only cut that if there is some basis. What is the basis? For that basis we go for the validation set. Okay, and the validation set is a, we have discussed earlier that if you have a database, if your database say this many number of items you have, so you take 80% of the item for the training and 20% item for the testing. Okay, typically, okay, I'm not telling it is always going to happen, but out of these 80% item, you take out of these 80%, you take 70%. You take 70% for actual training, and 10% for validation. What do I mean? That you use this data to build the tree. So you have built up some tree. Okay, you have built up some tree. Okay, let's assume that you come up with this tree. Then you use the second database, that is a validation database, and you see what is the accuracy. So you find out, okay, acha, on this database the accuracy was 100%, but on this database accuracy was only 70%. Okay, so what you do, you try to see that if I cut this part, you cut this part and try to see what is the accuracy. It may be possible that you by doing this cutting, your accuracy may be 75%. Sometimes it may happen because somewhere you are getting the wrong things. You can locate them and you can cut that part. You saw that accuracy has been 75%. Then you are at the right track. You cut these things. Then again you find out some other place where you can cut. You find out, say, if you cut this part, your accuracy would be 80%. Okay, you cut this part also. So this is the way you cut. So how you go ahead, this is what it says, the criteria to determine the correct file size. One thing that you stop before, and another thing that you build your tree and then you cut some of the things. Use the separate set of examples called validation, as we are talking about, and then use post pruning, means you cut those things. And for this part, use all the available data for the training, but apply the statistical tests such as chi-square test to estimate whether the appending or pruning a particular node is likely to produce the important beyond the training data. So you are going to use some statistical techniques for that. Use an explicit measure of the complexity to encode the training example. Sometimes you can also see that what is the MDL. You see that in the previous class we have seen that what is the maximum distribution length. Sometimes you see that generating these things are not going to be important. We have seen an example into the previous class where we have seen that a hypothesis having two different a hypothesis having 3 part was bad as compared to the 2 part. So you can use those concepts to also stop growing the things, and this is the another approach. So we have discussed all these approaches into the previous classes. So hope it is clear to everybody. Any questions? Okay. So the same thing. Okay, so when you do like this, so your accuracy was earlier when you increase the size, and your accuracy was actually increasing, and but the testing accuracy was actually decreasing. But here you can say that this second dotted line that is in between. So if you do those kind of things, so you may be expected to go into this way. So what I'd say that this graph is important, that when size of tree grows, your accuracy increases. Okay, your accuracy increases. This this is for sure but you are now not and on the testing data you are expecting that this is going to be the behavior. Okay, but when you are post pruning the thing, when you are doing the pruning, so therefore this accuracy becomes better. Okay, if this was accuracy, you may be getting this accuracy. So at everywhere you can improve this accuracy. At every point you can improve the accuracy, and therefore your new curve is going to be something like that. Okay, so this is what is important to be known. Okay, but the drawback of this particular approach is very big, and the drawback is that to do this you have to actually do the validation, and to do the validation you actually take out something from the training data, and getting the training data is difficult, and if you have less number of examples, then sparing some items for the not for training, only for the tuning the parameter, again gives you the bad thing, because now you have less thing available for the training. Okay, number of examples available for the training reduces. That sometime you may not like. Okay, so we have seen this, and another approach is actually very important, very basic, that tells that infer a decision tree from the training set. Means given the training given the training data, you build the decision tree that is fully overfitted, and okay, all possible overfitting is actually allowed, and then you convert these tree to the rules, means what are the equivalent set of rules. Okay, so how can you create the rules? We have seen into this example also. There was the first thing here. Here we have written the rule. You understand that how can we write this rule? Okay, that is very straightforward. Outlook is equal to sunny and humidity is equal to high. Then it is, and then it is no. Humidity is equal to normal. Then it is yes. So can you given this tree, can you write, given any tree, can you write this kind of uh, these kind of expressions? Yes, no. You can write out these kind of expressions. Okay. So when this kind of expression is given to you, this is very equivalent to that we have studied into the previous class. So what you can do, you can do the generalization. At some places you can put the question marks. So this is the rule post pruning, that initially you actually grown the tree and then convert the learned tree into equivalent set of rules by creating one rule for each path from one rule for each path, and then you generalize this. How can you generalize? You put some places you can put the question mark. How can you put the question mark? You can put the question mark at those places where you don't see that by putting the question mark accuracy is not going to be lowered. Okay, or sometimes you can do it based on some extra validation set. Okay, so for example, this is the tree. You find out this is the, you write out these kind of expressions, that outlook is equal to sunny and humidity is equal to high, then play tennis is equal to no. You find out this, and then each rule is pruned by removing any antecedent or the precondition. Means sometime if you see antecedent means here, sometime you see that humidity is high is equal to may not be required, but that depends upon the your validation test. Okay, you see the validation data and you try to see the accuracy on that, and sometimes you see that if on the validation set this you got from this tree, but now you can remove some of the conditions by seeing the validation set. On the validation set, you see that humidity is equal to high, doesn't make any difference into the accuracy, or it makes the, if you remove this, then your accuracy is going to be high. So you remove this part until the things are not lowering for all other things which are actually not badly affecting your validation set, accuracy of your validation set. You are removing all of those things from the set, and then there is lot of rules is given to you. For example, if outlook is equal to sunny, humidity is high, then play tennis is equal to no. This is the rule. And if you see that removing humidity is equal to high is making you better, so you remove this and then try to see what is the best accuracy. And it may be possible if you remove something only, you can remove. You cannot remove all the things. And when you get the smaller rule, then you try to see that what is the accuracy, and if that accuracy is, if that, and then you rank all these rules based on the accuracy. Okay, you rank all these things based on the accuracy, and based on this thing based on the accuracy, and when a new item comes, you use these rules for the classification. Is it clear? So somebody is asking, sir, can you please explain pruning and post pruning, rule post pruning once again? Okay, so let me tell you that what it is. The idea is very simple. That given the data, you divide into three parts. Okay. Okay, let me just take it here. Okay. Okay. The idea is simple. That it tells that. Okay, let me just remove this thing. One minute. Okay. So what I was telling, that data is given to you. Okay, the training data is given to you. Okay, let's assume that this much data is given to you. This much data is given to you. What you did, you taken out some portion of the data. Okay, and for the validation. Okay, you use this data to create the tree. You use this data to create the tree. When this tree came out, you wrote like this, that you wrote if outlook is equal to sunny, okay, outlook is equal to sunny, and humidity is equal to normal, then plate NS is equal to yes. Okay, you write this expression. Then you see the validation test. Okay, here somewhere you would be seeing that there would be sunny and there would be normal and it has been classified no. You can find out something. If it is classified no, then this rule is not good. Okay, then you remove this thing. You remove if something is, if outlook is equal to sunny, then plate n is equal to 1. Now the rule has changed. You see that if with respect to this, what is the accuracy? You may be seeing that with this rule is better, and with this accuracy, earlier the accuracy was 60%. Now your accuracy is 70%. Okay, lot of rules are there. All these things can constitute for the rule. So you see, similarly you put everything and you put a modified version of all of them, so that earlier if the accuracy of this was on the database 50%, and then you say 60%, and every rule is actually changed to get the better thing. Some of may not be changed, because when you change something the accuracy goes down, therefore you take the same thing. You understand this? You understand this thing, that if you use this rule on the database you are getting something. Then you rank all these things based on the accuracy. Means this is a 60% accuracy, so you put it up. This is somewhere you can be getting 65% accuracy, you put this rule up to this rule. So all the rules are actually ordered. Then all the rules are ordered. So when a new item comes, you utilize this particular thing, these rules one by one, and try to see what is the accuracy. And then you see that using this thing, the probability of being yes is 60%, and then probability everywhere you find out what the probability, then summation of those numbers, and then you can, by this you can find out the actual probability, because then you can go and find out the normalization, the value, the summation where the things are higher, you can use them for the classification. Is it clear? So moving towards more generalized rule through the post pruning, correct. So this is how, this is important thing. So that's all I have today. I was thinking that we would be taking longer time, but since we have skipped a lot of calculations, I think we have completed this earlier. Any more questions? So this is the last slide, and then I think maybe may have talked these things also into this class, but maybe it is fine to have them into the next class. Next class we have Zc4.5 algorithm and random forest, and we would also see the clustering with the k-means in the last class. Okay, and the syllabus. So many other times you are asking that what is the syllabus for mid-sem examination, regular examination, and that is the things that we are going to cover into the next class. Means they would be having the questions from the clustering with the k-means and the random forest. But most of the time I think that today's class, whatever we have covered is going to have the more weightage. Okay. Somebody is asking that can we have a walkthrough session and walk through what is covered so far. That is a nice idea, but let us see that how can it possible, because this is a big syllabus. Okay, I want to give you a lot of things, and hope, as I am telling that, although it is written till next class, but you can consider whatever we have discussed till today class, you would be able to get good marks out of that. And tomorrow there is no class. Okay, can you give an example of how to handle continuous attribute while constructing a tree? Somebody is asking that can you give an example on how to handle the continuous attributes while constructing the tree. So actually we would be seeing this into the C4.5, but since you have asked this question, let me just answer that. Let's assume that you have continuous attributes somewhere. So you can say that let's have continuous probability. Give me the example of some continuous attribute. Can you give me the example? Weight. Very good. So let's assume that I have a weight. Okay. Let's assume that I have weight. Okay. So you can say the weight is greater than WT is greater than 0 and it is less than 20 kg. Then you say it is greater than 20 kg, less than or equal to 20 kg, greater than 20 kg, weight is greater than 20 and less than equal to 50 kg. Another category could be greater than 50 kg and less than equal to 100 kg. So similarly you could find out those things. Okay, are greater than. So if essentially you can say that if weight is less than 20 kg, weight is 20 to 50 kg, and weight is greater than 50 kg. So these are three categories you can, in the similar way, you can form. Is it clear? This is one way. How do you partition the question? Okay, now how do we partition these into such intervals? Okay, the question is how do we partition this into intervals? Okay, so okay, to partition them, you can by yourself think that you say that you write this as a V1. Okay, you write it as a V1, V2 and V3. Okay, so you can say the weight is V1, weight is V2, weight is V3. Okay, let's assume the database is this. Okay, this is class and weight. Okay, weight is given 10 kg, 20 kg, 30 kg, 25 kg, 50 kg, 51 kg, 32 kg, kind of this. Okay, there could be some class say. There could be some class say. Let me just write here. Let me just quickly write yes. This is yes. This is yes. This is yes. This is yes. And let me say that all other places it is no, no, no. Then this database is actually transformed into another database. You are not going to use these values. Instead, you are using this value. Okay. If it is less than 20, you are telling V1. You take this value V1. This is V1. This is less than 50. It is V2, 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 and here it is greater than this. So therefore, you can say V3, V3. Okay. Weight is now this. Weight becomes this thing. Weight is V1, our weight is V2, weight is V3. Is it clear? From the exam point of view, what kind of question would be asked? I don't know, because when I would make the question paper, then only I would be there. Okay, is it clear? Is it clear? I think okay. Thank you very much, and for being in this class. It was wonderful. In case you have any doubt, please let me know so that I can clear it. Okay.